Okay, in the last video we looked at what makes a polygon. Now let's look at how do we name one or classify it. And you remember when we talked about triangles, we could classify the triangle by either its angles or its sides. When we're looking at polygons, we're only going to classify it by its number of sides, but that kind of makes sense because the number of sides and the number of angles are the same as we saw in the last video. So really, when we're looking at the number of sides, we're also looking at the number of angles, and we're also looking at uh, um, the number of vertices. Now, so when we're looking at sides, these names and the name of the polygon go together. So you're going to be expected to know these. So you kind of want to memorize this chart and memorize these. Some of them you'll know, some of them might be new. 3 sides would be a triangle. We already know that. 4 sides is what we call a quadrilateral. 4 sides, quad. 5, pentagon. Penta meaning 5. Pentagon, the Pentagon building in Washington, D.C., where our military is centered out of, is a pentagon. It's called the Pentagon because it's actually a 5-sided building. 6 is hexagon. Notice we don't have 7. That's a heptagon if you're concerned about that, but we don't use it a lot this year, so that's why they skipped it. We're only going to use mostly pentagons, hexagons, and octagons. 8, octagon. 9, nonagon. 10, deca, like a decade, 10 years, decagon. 12 is dodecagon. And then n-gon, n representing any number. So when we're talking about we could use any number. We could use 100. It could be 100-gon. Or if we did 150 sides, it'd be 150-gon. Or these, we could use a 4-gon or a 5-gon, but because we have these special names, we go ahead and use these. So n, you'll see used a lot in mathematics, and it usually represents an unspecified number of sides that could be used. So when you see n-gon, you just want to know that you can substitute in any number for that. Okay, so that would be how you would classify a polygon, by those names. And again, I expect you to know those by heart, so when you see them on a quiz or a test, you'll be able to know which each one is, so make sure you memorize that. Okay, next I want to look at convex and concave polygons. A convex polygon has no diagonals with points outside the polygon. Well, that means we need to know what a diagonal is. And a diagonal is a segment that connects two non-consecutive vertices. You'll notice that R and A are consecutive, and so when we connect those form a side. But if I take R and D, which is not consecutive, and connect those, you'll notice that's called a diagonal. And then you'll notice R to Y is also called a diagonal. Now it doesn't go diagonally like we think of in our mind, it goes straight across. But if we look at the definition, a diagonal is simply any line that connects two non-consecutive vertices. Well, R and Y are not consecutive vertices, so this line that connects them would be considered a diagonal. Okay? And then you have R and T, but that would be a side, those would be consecutive. So you draw all those, and then you go to the next vertex and draw all those and all those. And so you look at all these diagonals, and if none of these diagonals end up outside of the polygon in any place, that's what makes a convex polygon. None of the diagonals end up outside. However, in a concave polygon, you'll notice that if I draw the diagonal from P to the non-consecutive vertex Q, notice this diagonal ends up outside of the polygon. So because it's outside, that's what we would call a concave polygon. So concave polygon has at least one diagonal where some of the diagonal, doesn't have to be the entire diagonal, just any part of it ends up outside, then it would be considered a concave polygon, whereas if all the diagonals end up inside, it would be considered a convex polygon. Okay, so make sure you know how to number those, or how to name those polygons, and know the difference between convex and concave, and that's how we classify polygons.